Slope of a line. What is the slope of a line? In this video, we want to understand the concept of the slope of a line using several examples. So consider this line. So if we move on a line, we can decompose that movement. Let's assume we move from this point to this point. So we can decompose this movement into a horizontal movement and a vertical movement. And for horizontal movement, we consider a movement to the right as positive and a movement to the left as negative. And for vertical movement, we consider a movement upward as positive and a movement downward as negative. Then the slope of a line is the ratio of the vertical movement to the horizontal movement. For example, in this example, if we move from this point to this point, the horizontal part, if we decompose it to a horizontal movement and a vertical movement, so the horizontal movement is 1 unit and it is to the right, so it is +1. And the vertical movement, for example, it is 2 units and upward, so upwards is positive, so it is +2. So the slope of this line is m equals the ratio, so it's a ratio of the vertical movement, so the vertical movement was +2 divided to the horizontal movement, which was +1. So this is 2. Therefore, the slope of this line is 2. We could have we can go from any point to any point. So we could have gone from this point to this point. Let's do it from this point to this point. If we go from this point to this point, so this movement can be decomposed into a horizontal movement and a vertical movement. In this case, our horizontal movement is 1 unit to the left, so it is -1. And our vertical movement is 2 units to down, so down is negative, so it is -2. Again, if we write the slope of the line, which is the ratio of the vertical movement, so vertical movement was -2 divided to the horizontal movement, which was -1. So again, the slope of line, we get 2. So in short, if the slope of line is positive and we move from a point to a point, we always either go right and up or left and down. So we said right is positive, up is positive, and left is negative, down is negative. So the movement is always either positive or negative. Now let's do another example. Let's look at this line. So in this line, let's assume we want to go from this point to this point, so that our direction is, so we go from here to here, and we decompose this movement to a horizontal movement and a vertical movement. So our horizontal movement is, let's say it's 2 units, it's to the right, so it is +2. And the vertical movement is 3 units and it's downward, so it is -3. For this line, therefore, the slope is the ratio of the vertical movement, which is -3, divided to the horizontal movement, which is +2. So this is -3/2. And we could, as we said, it doesn't matter. We could do it for any points, any other points, or for these points, we could have gone from this point to this point. Now let's go from this point to this point. So if we go from this point to this point, we can decompose this movement into a horizontal movement and a vertical movement. So our horizontal movement, again, it's 2 units, but it is to the left, so it is -2. And our vertical movement is 3 units, but this time it's upwards, so it is +3. So if we write the ratio of the line, using this movement from this point to this point, then we can write it as the ratio of the vertical movement, which is plus 3, divided to the horizontal movement, which is negative 3. And again, we get negative 3 over 2. So in summary, for a line which has a negative slope, we either go right and down or left and up. So we said right is positive, down is negative, left is negative, up is positive. So we always go in a different direction. If we go in the positive direction of x, then the movement in the y direction would be negative. And if we go in the negative direction of x, then the movement in the vertical direction would be positive. So other than positive slope and negative slope, we have two special cases as well. In this example, for example, this is a special case that the line is parallel to x-axis. So in this case, when we move from any point to any point, we don't move in the y-axis, in the y direction. In the vertical direction, we don't move. So in this case, m is 0. And another special case is when the line is parallel to y-axis. In this case, for while the movement, we don't move in the x-axis, but we can move in any in y-axis as we wish. So in this case, the slope is undefined. And if we want to write the slope in formula perspective, so we can, for any 2 points, we can consider an x coordinate and a y coordinate. For example, this is point P1 and this is point P2. x2, y2. And we can write m as always as y2 minus y1, x2 minus x1. This is just the formulation, but we discussed the concept. And now using this formula, we can see why here m is 0. So if we consider this as x1 and this is y1, and this as x2 and this is also y2, so it's y2 equals y1 actually. Then m, using this formula, we can write it y2 minus y1, x2 minus x1, since y1 and y2 are the same for this line, which is parallel to to x-axis. Then we have 0 divided by x2 minus x1, which is 0. And for this example, if we consider 2 points on this line, then the x-axis for this point is x1 and y-axis is y1, and x-axis for this one is x2, which is equal to x1, and y-axis is y2. And now when we write m for this one, for this line, using this formula, y2 minus y1 divided by x2 minus x1 equals, so y2 minus y1, but x2 and x1 are equal, so this becomes 0, and division by 0 is undefined. That's why the slope of this line is undefined.